Thank you very much for joining our SWEEP webinar, Landfill Gas Management Technologies to Control Emissions, Landfill Emissions. With us today are Peter Quigley and Natasha Dyer, who I will introduce a little bit later. We'll take a couple minutes to allow folks to come into the webinar. And in the meanwhile, I'll introduce myself. I'm Rob Watson, founder and president of SWEEP, and I'll be the moderator today. I'm going to put up a poll that will ask a few basic questions. So if you could just take a minute, run through the poll, and give us your feedback, that would be most appreciated. I'll let that go for a minute or two, and then we'll start the introductions and the content. Okay, we'll let this poll run another minute or so. Let's try and get more than half of you all participating. It should be fairly straightforward questions. So today we're going to hear from Peter Quigley, who is the chairman and CEO of Loci Controls, and we'll be talking a little bit about the importance of landfill methane and some of the current techniques used to capture and control it. And then Natasha's going to spend some time talking about the SWEEP standard and how we in particular focus on methane issues in the context of sustainable materials management. So I'm going to close the poll in about a minute. So if you want to do the poll, please do it now. Appreciate all your feedback. It's really important for us to maintain good content and ensure that we are delivering the kinds of things that you all are interested in. We founded SWEEP about 6 years ago, and it was intended to be a quote, lead for solid waste, if you're familiar with the Green Building Standard, LEED. And it's trying to take a comprehensive look at sustainable materials management, not just focusing on diversion and recycling, which of course is the largest element of the SWEEP standard, but there are several other elements that Natasha will be talking about, and the effective and efficient operation of disposal facilities. And methane is probably the most important element of that, will be the focus of our topic today. So I'm going to end the poll, and I'm going to, let's see, share the results. All right, so we have lots of folks from the private waste industry and technology consulting, a few local governments, and several nonprofits. Most folks, the vast majority of folks, feel that methane is an important topic that needs to be addressed more. Some folks have gotten it taken care of. Love to hear about your experience in the Q&A later on. And it sounds like some folks would like a little bit more background on SWEEP, so we'll get to that very shortly. Okay, so I'm going to share my screen briefly and just introduce our panelists. Of course, there we go. Okay, and use the slideshow. All right, so Peter Quigley, as I said, is the CEO and chairman of Loci Controls. He's been in the space for a long time. I think it's really interesting that he has a bachelor's in ocean engineering. So clearly a very mechanically and solutions-oriented individual. We are really thrilled and privileged to have Natasha join us as acting executive director after being in the garment industry for over a decade. Fast fashion and sustainability in fashion is a huge topic, one that I hope that we'll be able to address later on. But her life changed when she took a webinar on waste management, particularly with a focus on organics. She spent several years working for private haulers, consulting firms, and most recently with the city of Atlanta, before we were able to bring her onto Sweep. So we're really excited to benefit from her expertise in moving sustainability management forward in the solid waste industry. Okay, so Peter, if you could fire up your slides, we'll be able to get going on your portion of the presentation. Feel free to use the Q&A to address questions, load questions when they occur to you, and then we will address them in the conversation at the end. Okay, so Peter, take it away.
Perfect. Thank you, Rob. Thanks, everyone, for joining us today, and looking forward to your questions. Really, the focus here is what is currently the most concentrated source of man-made methane emissions. Landfills are obviously enormous, but they're also quite literally hiding in plain sight. The subject of my comments are leveraging an opportunity to enhance the existing methane capture at landfills by leveraging real-time data and control technology. We believe that this is the largest, fastest, lowest cost opportunity to reduce greenhouse gas emissions at large scale. If the state-of-the-art methane control technology were to be operating on the 1,000 largest landfills in the US, we believe CO2 equivalent emissions using 100-year global warming potential of methane could be 40 million tons per year. It's the equivalent of 8.7 million passenger vehicles.
Peter, I'm really sorry to interrupt, but I'm not sure that the slides are advancing. Could folks raise their hand if they're not seeing the slides advancing? Yeah. Okay. That's better. Yeah. Okay. All right. So yeah, just wanted to make sure, because we were not seeing, we were caught on the cover slide there. My apologies for interrupting.
Okay. So let me just, instead of using the presentation mode, I'll just stay on this PDF mode, if that's okay, Rob. That way, make sure you can see the slides advance.
Absolutely.
But just so the backup here is just, that's a photo of a landfill. It's emitting a lot of methane in that photo. It's emitting methane 24/7, 365. Landfills are very closely connected with the atmosphere, very dynamic. The methane's being generated in the landfill in real time. So in many ways, it's much more dynamic and more complex than traditional oil and gas, where the hydrocarbons were produced millions of years ago and they're trapped subsurface. So they're only brought to surface through the extraction process. In just covering the data that I was sharing, and this PowerPoint will be available to anyone who's interested after this webinar. But the opportunity at the 1,000 largest landfills using EPA greenhouse gas inventory data would be to reduce CO2 equivalent emissions by 40 million tons per year, or the equivalent of just under 10 million passenger vehicles a year driven annually. We believe the cost to do this would be significantly less than $5 per ton. That's on the order of 20 times lower cost than wind, solar, or carbon capture technology. One of the great advantages of enhancing methane recovery on landfills is no land use is required, no infrastructure is required. You don't need to build power lines, rights of way, etc. So if you look at the overall EPA greenhouse gas inventory, and one thing I think of note, and I'm going to say this first, is there's increasing scientific consensus, and maybe this will begin to migrate into the world of policy, that using 100-year global warming for methane as a comparison to CO2 undercounts the negative impact of methane in terms of global warming. And more you hear the reference to a 20-year global warming potential for methane. The reason for that is methane in less than 15 years in the atmosphere breaks down. So essentially, after 15 years, there is no more methane in the atmosphere, whereas CO2 that's emitted today would be in the atmosphere for hundreds of years. It's really quite a shocking statistic when people hear this, but if no other estimates were changed, other than using the global warming potential of 20 years, methane emissions today account for the largest source of greenhouse gas emissions globally as well as in the United States, more than the entire utility sector, more than the transportation sector, and more than heavy industry such as cement and steel manufacturing. So really just on the basis of considering methane on a 100-year basis, the EPA estimates methane accounts for 10%. If a 20-year global warming potential of methane were used, the number is over 25% greater than any other industrial CO2 emission source. So it's really quite an extraordinary thing to consider that for 40 years, really most policy and effort has been directed to CO2. And yet methane is the largest source if you measure it on a 20-year basis of greenhouse gas emissions. If you look at the breakdown here, and I've just kind of set it on the 100-year basis, the estimate is 16% of overall greenhouse gas emissions are due to methane, and that number would be closer to 30% if a 20-year global warming potential were used. If you look at the large man-made sources of methane emissions, there are really three: livestock, natural gas, and solid waste landfills. And I heard a presentation from the American Biogas Association, and the executive director was giving this presentation, said there were 8 billion sources of livestock emissions in the United States. Cows get the most attention. They produce methane two ways, but all the decomposing manure from all the other livestock in the United States is coming from 8 billion animals. In the upstream oil and gas sector, there are somewhere between 1 and 5 million point sources of methane emissions. And if you look by contrast at about half of the estimated emissions, there are really only 1,000 large landfills in the United States that account for the vast majority of the methane emissions. So if you were to do a emission per site, the methane emission concentration coming from the 1,000 largest landfills in the US is several orders of magnitude greater than upstream oil and gas sector, and many orders of magnitude greater than livestock. So just in the way of thinking about, well, what makes it easier to fix? Well, if you only have to do 1,000 essentially initiatives to vastly reduce methane emissions versus a million or tens of millions, you kind of get a sense of how, just on a very high level, conceptually, landfills are really low-hanging fruit in terms of the opportunity to reduce emissions. Why this is important, this is very new. In the June of 2021, for the first time, the UN IPCC concluded that reducing methane emissions by half was the single greatest priority to slow the rate of global warming. And if the world failed to reduce methane emissions by 2031 by half, we will not stay below 1.5 degrees C which has been considered, this call it a climate yardstick for many, many years. Just would not be possible to achieve that. By November, so if you just look at the timeline, June 2021, for the first time, methane emission reduction was identified as the single most important short-term priority. By November of 2021, behind the US and the European Union, more than 120 countries had signed a pledge to reduce methane emissions. And that number has now grown to over 150 countries. So there's essentially an emerging policy consensus, if you will, or scientific consensus that methane emissions are the single highest priority to slow the rate of climate change. And yet there isn't the corresponding policy behind it that actually catalyzes the activity that I think is necessary to make sure this happens in a very short time frame. Just a high level, and I won't get into too much detail here, but landfill by composition is roughly 50% by volume methane, 35% by volume carbon dioxide. In the absence of any atmosphere or oxygen, the numbers would be slightly higher, but a typical landfill gas collected is about 50-35, with 15% being a combination of nitrogen, little bit of oxygen, and then some trace elements. Starting in 1996, and it was an evolution of the Clean Air Act that came out of the 1970s, was for the first time the requirement that larger landfills in the United States had to put in active landfill gas collection systems. Those regulations I'll get into briefly, but those regulations to this date, more than 25 years later, are still the primary way in which the industry operates the landfill gas collection process. And what I mean by that is, since 1996, landfill gas collection has been not driven to maximize methane recovery. It's been the operating requirements have been to ensure that operators meet or exceed minimum regulatory standards. So what do these regulations do? Well, they did two very important things. They essentially designed the system. They establish the parameters in which the collection system would be designed. And the primary design criterion is this: the system had to be sized to be able to collect the design amount or the modeled amount of methane that would be generated during the operating lifetime of the landfill. The collection well spacing was specified to be a maximum 200-foot diameter, and the time to ensure that you had a collection system was 5 years after waste was initially landfilled, or 2 years after the waste was at final grade. So the vacuum needed to be sufficient to collect the gas that was being generated. The collection points needed to be at spacing, which was equivalent to approximately 1 acre spacing on the surface of the landfill. And the collection system had to be installed within 2 years after the waste being at final grade. Then how was the system needed to be operated? The first level was surface emissions must be kept below 500 part per million, measured once per quarter, with a handheld measurement device with a technician walking on a grid. And you might imagine, if you had 500 parts per million measured between 5 and 10 centimeters off the surface of the landfill, over a landfill that was hundreds of acres in size, that even the regulatory threshold for methane emissions was very, very high in terms of the quantity of actual methane emissions. But that's been the standard which has been in place for 25 years, that the surface emissions as measured quarterly must be below 500 parts per million. Individual collection wells need to be measured, and they're often adjusted once per month on the basis of that measurement. The collection well must be on negative pressure. the landfill gas temp and oxygen or nitrogen concentration must be below a threshold. So going back 25 years, really the basic design of the collection system as well as the operating was more or less established by regulations. And historically, there hasn't been a great incentive for landfills to actually go substantially beyond what was required per the regulations. So the net effect of this, what is the net effect? Well, nationally, the EPA estimates landfill gas collection efficiency is 58%. And you'll see commonly for example, a California GREET model or industry estimated collection efficiency of 75 or 76%. These will be the numbers that are very commonly referenced for estimated collection efficiency. Today, there is no direct measurement of collection efficiency. You can measure the amount of methane captured, but you have to model the amount of methane that is generated. And to date, and this is changing because there's a lot of effort underway to have direct measurement of methane emissions. But currently, the efficiency is based on a model of the amount of methane that's being generated. And of course, a model is subject to disagreement about what the actual rate at which the methane is being generated and what the overall content is, for example, in the organic waste that's been landfilled. So from a current performance standard, direct measurement of methane emissions is emerging. There's a lot of flyover methane emissions data. There's a lot of satellite data, ground-based, drone-based. And I think the issue of what is the actual emission from landfills is going to become more or less settled within the next 5 years. The expectation that the collection efficiency, whether it's 58 or 76, there's significant room for improvement because historically there hasn't really been a drive to maximize resource recovery. Biogas to energy is increasing in value, but so is the cost of emissions. In other words, CO2 equivalent emission reduction is being incentivized through voluntary carbon markets, through state programs such as LCFS, and federal programs that is beginning to put a price on carbon that is going to make the emissions avoided as valuable as the biogas to energy market, in my view, in the future. So I think really just at a very high level, historically, gas collection system design and operations has been designed to meet regulatory requirements. And this, of course, doesn't equate to maximum resource recovery and minimizing emissions from landfills. So I'm eager to entertain questions. I'm going to keep going, but that by way of introduction is the backdrop of 25 years of more or less solid waste operating business as usual. So why do I believe that this paradigm from operating to meet regulatory requirements to maximizing methane capture and emission reduction is going to occur? It's increasingly aligning with municipal solid waste company brands, as well as community values, where communities are looking to publicly owned landfills to be innovating in a way that is trying to reduce their environmental footprint. It supports many stakeholder goals. It's consistent with financial market drivers. It is, and it's going to increasingly create new sources of value and compelling financial returns. The opportunity to make investments that reduce emissions and then monetize those emission reductions by going above regulatory requirements is going to be very compelling for the solid waste industry. And as I said earlier, I believe, and I think the data will support this, and I think when we look back in 5 years and we see the impact, this is really low-hanging fruit. The landfills are there. We know where they are. A lot of the infrastructure is in place that can be leveraged. The technology is well established. It's really just a question of shifting the paradigm of how we think about gas recovery and gas collection at landfills. We believe the key is leveraging real-time data and new control technology because the infrastructure is there, but traditionally the infrastructure has not been managed in a way that takes advantage of call it the developments of the last 25 years to provide real-time data that can enhance operations. So I won't belabor this, but let's just say, it's a very complex process. The collection systems are pretty well built out of Home Depot plastic pipe, duct tape, clamps, and PVC, flexible hosing. Lots of sources of air intrusion. Landfills, of course, are not impermeable. So when the weather changes, atmospheric pressure, if it rains, if it's a drought, all these things affect the permeability of landfills. Vacuum is not uniformly distributed. You think about the vacuum collection system in a landfill, it's a lot like a central vacuum system, but landfills are a lot more complicated than houses. They tend to settle over time. Pipe can get crimped, water can get into the subsurface piping. So there's lots of ways in which landfills are a very dynamic environment for trying to maximize methane recovery. In many ways, much more challenging, in spite of the fact that it's on the surface, than oil and gas recovery traditionally. I'll show a brief animation that shows really call it the enabling capability of having real-time data and control. Can everybody see this?
When organic trash decays in land.
Just wanted to, maybe Rob, you can give me a check. Can people see this video?
The video's not playing. We heard sound, but we did not see actual video.
Okay, so let's see.
Full screen,
Let's see.
Not just the PDF presentation.
Yeah, let me see if I can just switch us over here. All right, let's try this. Sorry about that. How about this?
It generates methane,
Good.
significant greenhouse gas, which is extracted through subsurface piping to be used for power. Historically, these collection wells have been monitored and controlled by field technicians who manually adjust the vacuum as needed. But this process has serious limitations and lacks precision. Technicians work only a fraction of the 24 hours a day in which gas is generated, leaving the system unattended for long stretches of time. And the manual tuning process can also be compromised by several other factors: air intrusions, atmospheric temperature and pressure changes, and inclement weather, which can't be immediately resolved by technicians. But there's a better way. Powered by new technology and supported by a manned analytics center, our landfill gas automation and control system provides 24/7, 365 support of the entire well field. A proprietary control algorithm maximizes methane flow while adhering to strict composition thresholds to find the sweet spot where methane percentage and gas flow increase revenue, reduce risk, and decrease costs. Rather than visiting wellheads, the technician can monitor his entire well field in real time from his desk. Generated data is routinely transmitted to the cloud, and a control algorithm under the supervision of the remote analytics center automatically adjusts the valve position to customer specifications. Too much vacuum means lower quality gas and possible elevated temperatures, and too little vacuum means emissions with lost revenue and potential odors. Automation keeps this setting just right 24/7. And no matter what the conditions, you'll be alerted of any issues within minutes. With your plant optimized, you'll increase gas flow by 20% or more while meeting your gas quality standards and mitigate the consequences of unexpected failures. Real-time data with 24-hour automation and remote analytics support means better landfill gas operations.
Okay, so now if I can navigate our way back to here. Okay, so just moving on from that point, really the before and after is when you have a manual process which involves a once per month visit to every collection point, you also then are troubleshooting more or less on an ongoing basis when something has been identified as going wrong by changes in gas composition, that you actually then have to go look into the landfill to identify and remediate. So the concept is really simple, but it is really a revolutionary change, is just providing data that allows the on-site experts, as well as simple automation, as well as remote, anyone who wants to be able to look at the collection process in real time, to be able to be more efficient, be more effective, and at the end of the day, substantially improve methane recovery and also reduce emissions. And that's really the extent of my my presentation. And I see that there's some comments in the chat. I think, Rob, you wanted to hold questions until we were at the end, but I'm really excited to have the opportunity to hear your questions and then be able to answer them as best I can. And thanks very much.
That was a great presentation, Peter. Thank you so much. Actually, most of the chat is me kind of running my mouth about sweep, but hopefully we'll get some more questions as we go. I'm going to turn it over to Natasha, who's going to explain a little bit about sweep and also specifically about how landfill methane opportunities are treated in sweep and rewarded. And then we'll get to Q&A at the end. Thanks.
Okay, there I am. I think I can be heard now. Thanks, Peter, for those very informative updates on the future of landfill gas and that the case is being made actually for more and more of it to be used, and that it's actually being landed, that's being heard. Because I always say, if we don't get them on the environmentalness of the best practices, we always get them eventually with their pocketbook, right? So thanks for that informative update. And as Rob mentioned, landfill methane is actually what motivated me to get into the solid waste biz. Just someone learning about the way organics decomposing in the landfill was like the third cause of methane emissions for mankind. I was like, why aren't we working on this more? So it's cool to be with Sweep for just these few months and actually be working, being faced with so much landfill or excuse me, methane and organics waste diversion. So I'll jump right into how Sweep basically. So yeah, I'm gonna discuss how the Sweep standard encourages landfill gas management in the industry through our certification process. Just go ahead and jump right in. And basically, those credits first and how they work to keep the momentum around the landfill gas discussion. And then I'll actually circle back to expand on what Rob was sharing about what Sweep is, how we came about, what our goals are, and how we're looking to revolutionize the solid waste industry. And so one of the things we want to do is ensure that waste is addressed comprehensively. And let's turn this off. And landfill gas would be no different, as it is obviously imperative to catch it from hitting the atmosphere, and then even more beneficial to be capitalized upon to have a second life and upcycled value. First off, it's very important to note that Sweep recognizes use of landfill gas and will give credit for an energy recovery system only if all attempts to mitigate that gas have occurred first. Since the highest and best use of organics is and not in landfilling organics, so that we're getting methane and keeping it out of the landfill in the first place, like we don't want that to actually even be what happens first. It means that the city or landfill should be looking at avenues to create policies or programs that divert and ban organic material from the landfill in the first place. because studies show that preventing a ton of food from entering the waste stream is 8 to 10 times more climate effective than any other post-collection processing. So, I mean, that's your anaerobic digesters, that's composting, the landfill gas capturing and turning it into a renewable source, that it's more beneficial if we just actually kept it out of the landfill to begin with. And so that's our sustainable materials management policy. Something we feel very strongly about and want to see mostly and more of is municipalities and these these materials handlers actually creating ordinances or programs that guarantee the sustainability of the diversion they have or will be setting about to create. So policies that support landfill gas are automatically seen as entities reductions in greenhouse gas emissions, and again, an entity that has organics waste bans. And so some of our other performance categories actually house credits for landfill gas management as well. You get credits for. And first, there's waste generation prevention. And this category has sustainable purchasing programs that establish energy efficiency and sustainability requirements for new purchases of capital equipment, construction, and infrastructure. So basically, these programs benefit creditors because they decrease costs over product lifespan and improve worker health and safety, and they offset carbon emissions and encourage sustainability amongst product suppliers. And so the next category, how SWEEP actually measures the effectiveness and the efficacy of the way local governments or handlers are handling their landfill gas, would be the solid waste collection. And this category is really, you earn credits by reducing greenhouse gas emissions generated by your trucks in general. This total category is just really focuses on the transportation of the collection side of hauling, and how it's being modified to have a less environmental impact as it is. So we're looking at, have you improved the fuel economy of your trucks by optimizing collection routes? Have you switched out your fleet for an electrified one? Or in this case that we're talking about today, have you been able to capture that landfill gas and then turn it into compressed natural gas for your fleet? Also, another category with which SWEEP can measure landfill gas and note its efficacy and being reused is our post-collection recovery credit. And this credit in general focuses on giving points for the circularity you're creating in your recovered materials stream and collections. Like, are they being recycled and brought back into new markets? But there are also credits in this category for sustainable buildings operations too. So just think of, like, I'd even say like lead for the solid waste facilities. So like, if is your water, the way you're using your water, is it are you using less of it? Is it efficient? Are you using energy in an efficient way? So if landfill gas can be used as a renewable energy source to power that facility, you're on the way. And so our next and final category for measuring performance is post-collection disposal. And same goes for the category just before, like, are you using landfill gas as a renewable energy source to power that disposal facility? And the final two big points for or credits for post-collection disposal, and these are the big points. These last credits want to ensure that landfill gas emissions are minimized to begin with, and that B, they are being recouped and providing a renewable energy source and an alternative to fossil fuels in offsite locations. Because both local government and industry or materials handlers, that landfill gas energy, they've been proven to be very successful methods of capturing and repurposing methane emissions as a methane-based electricity, and then also being able to then power other city fleets, and increasing the sustainability of waste management systems and increasing profit margins for those cities or those materials handlers. And so I just thought I would share some case studies of landfill gas at work and offsetting the use of fossil fuels. And so there's a BMW manufacturing plant in Greer, South Carolina, has been able to meet about 25% of its electrical needs and all of its thermal needs by pulling landfill gas from a neighboring landfill. And this has added up to about nearly 70% of this plant's energy coming from a landfill gas. And that also adds up to them reducing their carbon dioxide emissions by what would be the equivalent of driving 105 million miles per year. And so this project also stabilized BMW's energy prices, as they were able to contract with the local landfill to keep prices stable for a 20-year contract. That's pretty cool. And then this last case study is by Vogel Disposal. They're a waste and recycling hauler that owns their own landfill. And they've been able to fuel their 38 collection vehicles using landfill gas. And then they've been able to use so much of the excess that they've created some public fast fill stations, and that's being used again for other city vehicles, buses, and other city fleets. Let's see. So those were these are our 5 performance categories I was just able to go through pretty quickly, that how they pertain to landfill gas. And then after adding all the points up, and there's many other things that are measured for a whole life cycle of a solid waste operation that go into all of these categories. But once you add them up, they add up to be about 100 points. And then there's also some space in there for innovation. So that's basically if you've come up with anything nifty and clever that we haven't seen, that's actually a good business practice and creates great solutions. And so after that's all added up, we are rating you just in platinum, gold, silver, and certified. Let's see. And I'm used to giving these presentations from start to finish, where I talk about sweep and then kind of talk about the credits. So I'm just a little, so I'm just going to now circle back and start talking about basically who we are. And I think it'll just make a lot more sense before talking about the credits and the points. And I'll try to circle back to some of the performance categories and how they add up. But basically, let's see, SWEEP, which stands for the Solid Waste Environmental Excellence Performance Standard. It has a vision of the world without waste, where all of society's discards are viewed as commodities to be continuously cycled back to their highest and best use. And it's really came about in response to the US EPA's framework on sustainable materials management that was released in 2009 to focus on the value of using and reusing materials and keeping them circular. And so this is what we're trying to complement at SWEEP. I mean, it's all we talk about is sustainable materials management. And so this is the mission. It's a transforming of the solid waste industry to one of sustainable materials management, which is better for people, planet, and prosperity. And I know Rob introduced himself at the beginning, and just a little bit about how SWEEP came about, really. It's really thought of to be the lead for solid waste. And LEED, as a lot of you might know, it's the largest, fastest growing, and most recognizable green building rating system that's in about 170 countries now. And so basically, Rob noticed the same thing when he was trying to create this new measurement system for solid waste, is that basically, or he noticed the same thing when he was creating LEED, that when he was trying to create this new measurement system for solid waste, that basically there was no definition, right? There was nothing that we were universally measuring together as an industry to determine just what was being diverted. There's no standard, really. We weren't speaking the same language. So if we have no standards and definition, how can we even know what we're measuring or calculating as real diversion by city, by municipality, by jurisdiction, region, nation? And so take, for instance, the common category of green waste. This is a common resource and the waste stream that is quantified and reported in a city's diversion metrics, right? But as we all know, what is characterized as green waste can differ from city to city. Sometimes by the time you get to your job, they're measuring or recycling things in a totally different way. So in some cities, green waste simply refers to yard trimmings. And then in some cities, as we know, green waste is the commingling of your yard waste and your food scraps. And so then what do we have if we're not measuring all in the same way, right? And so SWEEP is setting about to create a standard framework to provide a consistency in the way we talk about our waste, the way we define it, the way we measure it, and the way we report it. And so let's see. Some more information about really who we are, how this all works. So similar to the True Standard, which on a micro level assesses how well actual facilities and their operations perform in minimizing what they send to landfill, trying to create true circular solutions for their discards. SWEEP then certifies good diversion practices on the macro level, zeroing in on the ecosystem that's the materials management industry. So SWEEP is looking at where materials are ending up once they've left that building and hit that curb and then gotten on the truck and then gotten to the transfer station. Like, are these resources headed to a MRF for further separation, like treated as that valuable resource that they are? Are they headed to landfill where they will lose their next level of worth and value forever? Or until we figured out how to urban mine, right? So we're really just trying to certify, like making sure that all of these things that are being said to be recycled, like let's just make sure they're getting back into another market. And another note on True, I've kind of made a connection with for myself has been that I feel like we look at True as being a kind of real first defense against waste, since that's the great market signal back to the manufacturers that the business doesn't even want this type of material because it's not recyclable. So I feel like it's this way that we start to really attack upstream designing out waste, and until we start saying, hey, we don't even want this in our facilities, forget what, so that we don't have to deal with it once it gets to the curb. I think True is going to be a real good benefiter of that. So let's see. And so, too far. And so because of this model analysis, like how Sweep is looking at the entire ecosystem, like the once it hits the curb and once it's collected and goes away from the curb, the only parties eligible to participate in Sweep getting certified are local governments and the material management handlers. I mentioned already, the haulers, the MRFs, the transfer stations, your composting facilities, anyone who's handling C&D discards. And then membership with Sweep is then extended to nonprofits and consultants and waste brokers, even though the municipality or the local governments and handlers can be members too. It's really, if you're not in that space, you cannot be certified. But members are very important to Sweep because the certification manual, let's see, that I'll share here, how we actually measure the step-by-step instructions on how to certify, that gives in-depth cases on best practices. These tools were actually created by subject matter experts giving thousands of hours of their time. And we're talking about people that have had like decades upon decades sometimes in the solid waste or sustainable materials management communities that have actually given this great amount of time over the last 6 years to keep developing what it means to define our waste and what it means to measure it. And so these are the tools that we use, that any certifying entity would get to actually go through and figure out best practices. And then our reporting tool is Retrack Connect, which I think is familiar to a lot of people. There are some other reporting mechanisms out there like MMP, but this is one of the industry known reporting portal. And so here's a listing of a dozen or so of our Sweep Plus pilot participants, spanning local government and industry. A few of who are hopefully going to certify this year, but news on the way. I do believe Spokane will be certifying before Earth Day. It is their goal to get certified before Earth Day, and so Sweep should have an official certified local government within the next couple of weeks, and we are very excited about that. With a couple of these cities, like I said, on the horizon to be certified just within the next couple of months as well. So we are very excited about that. I know I like to always give the stat that I know when LEED came out, I think it took about 15 or 18 years or so to get it going, get it on the ball, and now look at all the success it's had. And so Sweep to be getting this far, I think in 6 years is kind of exciting. So let's see. So some benefits of actually going through the certification process with Sweep is that when you become Sweep certified, it's been shown that municipalities that get involved have 25% more diversion. And this, of course, saves money from landfill tipping fees. And you're also showing your constituents that that you're a leader in sustainability, something that I'm sure we all know more residents are much more tapped into these days and actually care. And so a third-party verification system is giving them a clearer view of your impact and that you're willing to be have someone look underneath the hood and not that you're just saying you're sustainable. Also, with more young people being concerned about linking themselves to sustainable and climate efficient causes and business models and bottom lines, you'll be able to attract a younger, educated, and innovative workforce who want to align themselves with corporations who are walking the talk. So again, if you're interested in becoming a member, let's see, these are some ways to get involved. You can either go through a pilot participation or certifying your local government or your industry business, or you become a member. And these are some of our members, because I think we're just trying to speed up. We're running out of time, I believe. And so these are some of our members who have weighed in on our wonderful certification process. And some benefits of becoming a member or that you actually then can become one of these persons, these subject matter experts who continues to weigh in on the development of SWEEP by attending and becoming a part of some of our technical committees. Also, when we roll out our equivalent of the lead GA, which will be us like a SWEEP accredited professional, you can get that first dibs on that. And just like Losi did today, we'll also showcase you on a webinar so that you can highlight anything that your company is doing that you feel like is innovative or something you're proud of. And we also love to get our new members announced on some of the waste magazines that we have relationships with and get press releases. So yeah, so that's SWEEP to my knowledge of the last few months of being here. And if you have any questions, please ask them now.
Excellent, Tasha. Thank you so much for that really great presentation. Peter, also, thank you so much. We've got about 10 minutes and a bunch of really interesting questions that definitely want to go to. I'm going to take the first one, which is, would both the company and the municipality earn the credit if they engage in landfill gas management, even if the company is operating a landfill? Short answer is yes. We have a mechanism called reciprocal credits. And basically, the idea behind reciprocal credits is that this thing needs to be done. We don't care who does it. If it gets done, both parties, because the local government under SWEEP is on the hook for everything. If you're in the industry, you're only on the hook for stuff that you actually do. So if you're just a hauler, if that's all you do, we do expect you to have some corporate policies. We do expect you to collect certain kinds of data. We do expect you to meet all of the solid waste or most of the solid waste collection elements, but you're not on the hook for the recovery piece. You're not on the hook for the disposal piece. Local government has to do everything. So basically in a reciprocal situation, say a landfill gets its operations certified and the entity operating the landfill is, that's all they do. Everybody who, all the municipalities and all the companies that service that landfill have the ability to get credit for that without having to document it. You just need to point out, or the landfill basically needs to say, hey, here's our SWEEP certification. And all you do is check off the box, because what we're really trying to do is minimize the amount of documentation, the amount of administrivia that people have to do in order to certify to SWEEP. So that's why we have the reciprocal credit. If one person in that chain gets it, then everybody within that chain that's directly applicable to it gets that credit. So switching over, so question for Peter. Peter had a couple of questions. Just quickly, if you could just share your answer, Peter, about the expense and how to get around the issue of monitoring methane. I think that would be important for a lot of folks to hear.
Yeah, so a question was about, are there existing and or emerging relatively low cost methods for measuring methane emissions at landfills? And I think the short answer is no. Satellites are really good at picking up very large concentrated sources of emissions. It might see a landfill where the flare is not lit, as an example. So all of the captured methane might be picked up by a satellite, but isn't going to be very good at picking up 100 ppm of methane concentration spread out over hundreds of acres. So I think this is an area of enormous amount of activity. There's an emerging industry of methane emissions measurement from planes, satellites, drones, ground-based, permanent installation. There's an enormous amount of activity. So I would suspect in the relatively near future, and that's years, not months, but say 3 to 5 years from now, landfill methane emission measurement is going to be quite commonplace. It will be economical, and it will probably be a routine part of operations. It just isn't the case today.
Thanks, Peter. Okay, so Natasha, somebody asked, does SWEEP consider the type of items that are being disposed? More specifically, is there a comparison of the disposed item versus what the market would support or consider as recoverable? You'll need to unmute.
Please answer. Please take that one, Rob.
Okay, so short answer is, for example, if there is a market for something, even hypothetically, like glass, it would not be using that material either as, ADC or paving the road, the road up the face for the landfill would not be considered a recycling or a diversion technique. So basically, anything that is considered, quote, recyclable should be recycled if you want to get credit under this in SWEEP. Now, we are looking to get away from the diversion metric as sort of the sole way of looking at program performance. And we are also looking at per capita disposal as an alternative compliance path if, say, the diversion numbers are not good. And so that's one of the ways we're trying to get away from the ton, which is a meaningless metric from an economic or environmental perspective, and look more comprehensively at the environmental impact and the economic impact. Here's a question for you, Natasha. Did the BMW plant have to create a connective pipe to the landfill to receive the gas, and how far away was the landfill from BMW?
Yes, they did actually. It was 9.5 miles away from the landfill. I'm just going to pull it up here. It says BMW built a 9.5 mile, 4,800 standard cubic feet per minute pipeline across complicated terrain, showing that landfill gas is a potential energy source for companies and municipalities that are not located right next to landfills. So it was a case they were making that this can be done, because I think it had to go over some real serious terrain, rocky terrain.
Excellent, thank you. So Peter, with such a compelling argument and presentation, what is inhibiting promulgation of policy to mandate automated collection of landfill gas?
So that's an important question. And, I would say that, the solid waste sector is a heavily regulated industry. And I think without understanding the impact of a new technology, my impression is they're not going to be fast movers to drive adoption of something which is relatively new. We believe that public policy that is creating financial incentives are much more likely the fast path to widespread adoption in the industry. I heard the Republic CEO speak at a waste event last spring, and he said Republic Services has 5 million interactions with their customers daily. That's in their homes, in their neighborhoods, in their businesses. Their primary responsibility is to ensure that they operate safely and that they meet all the requirements necessary to protect the environment and provide the services that they're called upon by society. We're the ones that create the waste, right? So I think they're doing what, one, regulations say is required, but two, operating in a way that is ensuring that they are operating in a very safe way. So I just think regulations as a pathway to driving change in a sector like municipal solid waste is going to be too slow. I think putting a $50 per ton on the price of CO2 emission reduction is going to catalyze rapid adoption. So we're very much focused on catalyzing existing public policy to apply to this application that's not been applied to historically, as opposed to regulations. But I think regulations will likely come, just it will take quite a long time. And by that point, hopefully, this will be kind of common practice. Hopefully that answers the question.
No, I thought that was a good answer. And as we used to frequently say in the green building movement, meeting the building code, i.e. regulation, simply means that if we built it any worse, it would be illegal. And that's, I think, a good way of looking at mandatory standards. They're designed to remove the worst actors, but they're not drivers of innovation. That's what the market's for. Just riffing off of your mention of Republic Services, there was a question if any Republic Services landfills are registered with SWEEP. Short answer, not yet. Would love to have them. We welcome any introductions to Republic. We think it's really, really important for the majors, particularly ones who are doing good jobs, to be part of our community. And then the final question from Bob Geddert, who, as a founder of the NRC and a longtime SWEEP supporter and a very, very important contributor to the early days, DAZE of SWEEP, comes a question that landfill methane capture efficiencies are greatly needed, but a local landfill operator is discouraging composting food waste as that program decreases its landfill gas output. The landfill operator converts the landfill gases to electricity for power grid. Lower organics equates to lower gases generated, which results in lower rebates from the utility. How can we convince the landfill operator toward landfill gas capture efficiencies while also encouraging food waste reduction and composting? Excellent question, Bob. LEAD discourages, SWEEP discourages the operation. In fact, we do not permit landfills to be operated as bioreactors. There are way better vehicles for capturing methane from food waste. And in fact, by the time a cell is capped, 70 to 80% of the methane that is represented by that food waste is already in the atmosphere. So so food is not a great source of landfill methane capture. Things like fiber and stuff like that, which take a lot longer to decompose, are much better sources of long-term methane generation and capture. However, that fiber is probably worth 5 to 10 times as much turning back into new fiber than it is into landfill gas. So I think, we're going to need to figure out new structures for dealing with food waste. I think Natasha very accurately discussed how Oregon showed that 8 to 10 times the climate benefit was received from preventing food from getting into the waste management stream. And so so for that reason, we're trying to create a new structure where the different components of the system are optimized for economic and environmental value. That does it for our web. Peter, go ahead. Have any final thoughts?
Well, I was just going to do very quickly, in the driest climate, organics that go into a landfill will generate methane for 50 years. In the wettest, hottest climate, it will be 20 years. There's a lot of opportunity to enhance methane recovery by shifting the paradigm. So I think the reality, organic diversion is not something that you can snap your fingers and have happen very quickly. But as it's happening across the country, there's large opportunities to increase methane recovery at every single landfill, whether they're accepting organics or not. So I think the reality is the stuff that's in there is going to be producing methane for 20 to 50 years. That's way too long, right? We have to do something about it. So I think that's the offset to the organic diversion is bad for landfill gas recovery. That's the counter argument that there's going to be increasing value society places on reducing emissions from landfills.
Well, I mean, again, landfill is just a version of a stomach, right? So just build different kinds of stomachs. Absolutely do all the landfills, but build other kinds of stomachs and other kinds of things that use critters to generate gas. And the other thing I think we need to get a handle on is how much methane is actually generated by composting food waste or even green waste. There's a lot more methane coming out of that process than people will admit. So we need reforms and maybe some capture vehicles for that as well. And
And can you clarify the technologies or the methods you think that the composting methods that you think are creating more methane? Is it the windrows at
well,
landfill sites,
things
or-
like fermentation, again, things that are, you use mechanical biological treatment types of things, within, rather than open pile and open windrow and stuff like that, things inside of structures where methane can be managed a little bit more effectively, alternative technologies such as, fermentation, anaerobic digestion's been around for a long time. I'm kind of also thinking that turning organics into biochar via microwave or other kinds of the gas pyrolysis technologies may actually also be a really, really good way of doing it. Still needs a little bit more research, but just because we touch something with a little bit of heat or energy doesn't make it a bad thing. So I think that book remains to be open, or is still open, and there's a lot more work that needs to be done there. And as my friend Robert Bolster just commented in the Q&A, that education is a key component to any reform. That's exactly what our webinar series is designed to do. Thank you so much for taking the extra few minutes. Sorry the webinar went over, but we deeply appreciate your incisive questions, your enthusiasm. Please check out our website, www.sweepstandard, SWEEPSTANDARD.org, to learn more about SWEEP. Join early, join often, help us transform the world. The species you save may be your own. Thank you very much, and we'll see you next time. That concludes the webinar.
Thanks, everyone.
Bye.